Hello everyone. In this video, we will cover some important MCQs on synchronous machines. The first question is the three-phase alternator is wound with a 60 degrees phase spread armature winding and develop 300 kVA. If the armature is reconnected utilizing all the coils for single phase operation with a phase spread of 180 degrees, the new rating of the machine is options are 100 kVA, option B 200 kVA, option C 250 kVA, option D 300 kVA. The solution is induced EMF in a three-phase alternator is E is equal to 4.44 pi f t kp kd. The given question provides only the phase spread values for single phase and three phase systems along with the EMF value of the three phase system. Here we have to find out EMF developed in the single phase system. Sigma is equal to 60 degrees. It is for three phase system. Single phase system of sigma is equal to 180 degrees. We are using phase spread while calculating KD. Now calculate KD value because E proportional to KD. The formula of KD is equal to sine sigma by 2 by sigma by 2 into pi by 180. Substitute sigma is equal to 60 in KD formula. We get KD of three phase system is equal to sine 60 by 2 by 60 by 2 into pi by 180. 2 ones are 2 30s are 2 ones are 2 30s are 0 0 cancel out 3 ones are 3 6 are 18. So we get 1 sin 30 is equal to 1 by 2 by pi by 6. 2 ones are 2 3s are 6. Next we get 3 by pi. Again, we calculate KD value for single phase system. KD of a single phase system is equal to sine 180 by 2 by 180 by 2 into pi by 180. 2 ones are 2 90s are 2 here 180 180 get cancelled out. Sine 90 is equal to 1 by pi by 2. It will rewrite it as 2 by pi. According to the question, KD of three-phase system produce 300 kVA. Then this three-phase of its armature winding reconnected to a single-phase system. Then new rating of the machine is. So KD is directly proportional to kVA. So we can write as KD of single phase system by KD of three phase system is equal to kVA of single phase system by kVA of three phase system. So 2 by pi by 3 by pi is equal to kVA of single phase system by 300. Pi get cancelled out. This 300 is go to the other side of the other side. Then it will cancel out 3 ones are 300s are 200s are 200s are 200. Then the new rating of a single phase machine is equal to 200 kVA. So here option B is the correct one. Next question. In three-phase star-connected generator, if the fundamental and third harmonic RMS voltages in each phase are respectively V1 and V3, the line voltage of the generator will be. Options are root 3 of V1 plus V3, option B root 3 times of V1, option 3 root 3 times of V1 plus V3 by 2, option D root 3 times of V3 by 2. Okay. For alternator or motor, stator is connected in star fashion. The phase voltage contains third harmonic components, but in line voltage does not contain third harmonics. So in star connected generator, line voltages are free from triplet harmonics. These triplet harmonics are V3, V9, V15. It is equal to 0. So line voltage VL is equal to root 3 times of V1. So here answer is option B, root 3 times of V1. Next question. A single-phase alternator has a synchronous reactance of 2 ohms and negligible resistance if it supplies 10 amps to a purely capacitive load at 200 volts. Then the generator EMF will be. Options are A 240 volts, option B 220 volts, option C 200 volts, option D 180 volts. Uh, so which option is the correct here? So we'll go to the solution. Mm. Resistance and reactance are mentioned in the given question. So we use formula of induced EMF of a single phase alternator. E single phase is equal to under root of V cos pi plus or minus IA RA whole square plus V sin pi plus or minus Ia xs whole square. Here plus sign is used for lagging power factor loads and minus sign is used for leading power factor loads. Here generator supplies a capacitive load. So I take pi is equal to 90 degrees and cos 90 is equal to 0 and sin 90 is equal to 1 and resistance is here is negligible. So E phase E single phase is equal to V sin pi minus Ia xs. V is equal to 200, sin 90 is equal to 1, 200 into 1 minus armature current is equal to 10 into 2. So, by solving this equation, we get 180 volts. So, here option D is the correct one. Next question. The distribution factor for a 36 slot with a 3-phase 8-pole winding having 120 degrees phase spread is. Options are 0.844, option B 0.644, option C 0.544, option D 0.444. In this question, winding have 120 degrees phase spread. So, sigma value is equal to 120 degrees. Here, we will find out distribution factor. We use the formula Kd is equal to sine sigma by 2 by sigma by 2 into pi by 180. Substitute sigma value here, then Kd is equal to sine 120 by 2 by 120 by 2 into pi by 180. 2 ones are 260s are 2 ones are 260s are 0 0 cancel out, 6 ones are 6 3s are 18. So here sine 60 is equal to root 3 by 2 by pi by 3. It is rewrite as 3 root 3 by 2 pi. Simplify these values, we get 0.824. It is nearly equal to 0.844. So here option A is the correct one. Next question. A 3-phase 4-pole alternator has 48 stator slots carrying the 3-phase distributed winding. Each coil of winding is corded by one slot pitch. The winding factor is given by. Options are 0.955, option B 0.976, option C 0.9494, option D 0.983. Okay, answer is here. What we have to find out here is that winding factor. So we use the formula winding factor Kw is equal to Kp into Kd, where Kp is the pitch factor and Kd is the distribution factor. For Kp, the formula is Kp is equal to cos alpha by 2, where alpha is the slot angle in electrical degrees. So slot angle in electrical is equal to P by 2 into theta mechanical. Theta mechanical value is not mentioned in the question, so we need to find out here. So theta mechanical is equal to 360 degrees by number of slots. Number of slots are given in the question is 48. So theta mechanical is equal to 360 degrees by 48. By performing this division, we get 7.5 degrees. Slot pitch angle theta electrical is equal to P by 2 into theta mechanical. So 7.5 into 4 by 2 is equal to 15 degrees. Alpha is the electrical slat angle, which in this case alpha is equal to 15 degrees. Substitute alpha value in Kp formula, we get Kp is equal to cos 15 degrees by 2. 7.5 times the 15, so cos 7.5 degrees is equal to 0.999. Next, we need to determine Kd value. Kd is equal to sin m gamma by 2 by m gamma by 2 into pi by 180, where m is equal to slots per pole per phase. M is equal to 48 by 4 by 3. We get 4. Here gamma is equal to 180 by slots per pole. 180 by 12 is equal to 15 degrees. Here phase gamma is equal to, sigma is equal to m gamma. 15 into 4 we get 60 degrees. Kd is equal to sin 60 by 2 by 60 by 2 into pi by 180. 2 ones are 2 30s are. 2 ones are 2 30s are. 0 0 cancel out. 3 ones are 3, 6 are 18. Here sin 30 is equal to 1 by 2 by pi by 6. 2 ones are 2 3s are 6 is equal to 3 by 5 is equal to 0.955. Winding factor Kw is equal to Kp into Kd. So Kp value we got 0.99, Kd value we got 0.955. Multiplying this both values we get 0.9494. So here option C is the correct one. Next question, for a 3-phase stator winding having 5 slats per pole per phase and coil span of 12 slat pitches, the value of pitch factor is options are 0.98, option B 0.951, option C 0.851, option D 1.05. Okay, the solution is here slats per pole per phase m is equal to 5. From this we can find out slat per pole by multiplying m with 3. We get 15 slats per pole. It is equal to pole pitch. Generally, we consider pole pitch is equal to 180 degrees. It is equal to 15 slats per pole. So, therefore, 15 slats is equal to 180 degrees. Then, 1 slat is equal to how many degrees? Is equal to 180 degrees by 15, we get 12 degrees. It is the value of a slot pitch. In the question, beta is given that 12 slat pitches. So, it means 12 into 12 degrees, we get beta value 144 degrees. We know that alpha plus beta is equal to 180 degrees. From this equation, we calculate alpha value. So, alpha is equal to 180 degrees minus beta. 180 minus 144, we get 36 degrees. Now, we need to find out Kp value. Kp value, we use a formula is here is Kp is equal to cos alpha by 2, cos 36 by 2. 2 ones are 2 18s are. So, here cos 18 is equal to 0.951. So, answer B is the correct one.